Welcome back to the net function, and today I will be sharing with you guys my IntellFuzz, a next generation web app Fuzzer, which I am working on for my FIP project, and I will be presenting it to Pakistan CyberSec Idea Cup. So basically, before I go ahead and introduce you guys with my project, I want you to know about fuzzing. So the fuzzing is a software testing where we inject random inputs to detect software vulnerabilities or system defects. So this was the case for traditional fuzzing, where a fuzzer part will generate random inputs and then we will inject those inputs to the system under test. And after that, the responses of the system will be observed, and then a report was built, which will conclude that whether it was prone to certain vulnerabilities or not. So basically, now you would say that what was the need? Why do we need, the Intel fuzz or the next generation web app fuzzer? So the problem was that the traditional fuzzing was great for fuzzing C++ or Java programs, where we just don't have to adhere to certain rules compared to the web apps, where the complexities of HTTP and HTTPS programs or the protocol just can't be addressed through a random channel. So this was the case, and then the other problem was that we got stateful interaction among web app or a client, where a client must have to in some cases have to maintain its session or cookies. So a traditional fuzzer wasn't just able to cope with these kind of changes. And after that, we got string it input validation. The input validation is much stronger compared to the C++ program, where you just can pass any kind of random input and then wait for a fruitful result. But in case of web apps, the input validation being carried out at the front end are very complex. Like, as you guys must have observed that we just can't pass a random string in the email field of a web app. And then we got after that we got authorization complexity, where a user must have to adhere to certain rules or policies mentioned in its IAM policy. So this was the case. Now our proposed solution, we will use machine learning to overcome most of these problems. So how will we use machine learning model? So we will train our model on all the previous malicious queries, or the we will train it on SQL queries or every kind of XSS scripts, and then we will be able to generate much more test cases, and those test cases will adhere to certain syntax or certain semantics. So this was the case which we were missing in case of traditional fuzzings. And then we will be carrying out sensitivity analysis. Now what will sensitivity analysis do for us is that it will filter out all those random places. As some of you might have known, that there are a lot of places in an HTTPS request where we can perform fuzzing, but most of them are not valid. Like, if we are fuzzing on our time-based headers, so it will not lead to some fruitful results. So we have to filter out some of the garbage places which are not providing any fruitful results. So we will be carrying out the sensitivity analysis through machine learning, and then the report which will be generated will contain much less false positive or false negatives, because our report or the system which will generate the report for us will be trained on the machine learning model, which will contain all the reports of the previous vulnerabilities, and then it will generate the report for us. So this was the basic introduction to the IntellFuzz. Thank you guys, and keep coming back to the channel and keep sharing and liking it.